Hi folks, we're going to take a look at page 111, number 10. So here they tell us that the width of a square-based tank is 3 less than the height. And they tell us that the capacity, in other words, the volume, is 20 meters cubed. So what they want us to do is they want us to find the dimensions of this tank, but they're only interested in integer values. Okay, so any answers we get that aren't integers, they're not interested in. All right, so anything that's got a physical significance like this, we really should be drawing a picture. So let's draw here a tank that's got a square base. All right, and so since it's a square base, it means these two dimensions are going to be the same. So if we follow what they tell us that the width is 3 less than the height. So if I call this the height, then the width and of course the depth, which has the same measure, since it's square based, would be h minus 3, and this would be h minus 3. All right. Now I could work with this scenario and I could solve the problem perfectly well, but right away I'm starting to think I'm going to have to work with the volume of this box. So at some point I'm going to have to multiply the base, the width, and the height. And so I'm going to end up having to multiply out h minus 3 squared and then times h. It's going to be a little more complicated than I need to work with, and let's see why. Because if instead of working with the variable h, I work with a variable to represent the width of the box here, let's say I call this x, and then of course that's also going to be x, then well, if the width is 3 less than the height, that must mean that the height is 3 more than the width. So this would be x plus 3. And you see that multiplying these three terms is simpler than multiplying those. Okay, so if you don't think of doing this, no problem. You could solve this problem using the above setup. All right, so what do they tell us? They tell us that the capacity or the volume is equal to 20. All right, but of course, the volume is just given by the length times width times height. So just x times x times x plus 3. And now what we've done is we've created a polynomial equation, okay, and something that we'll be able to solve. So let's multiply this out. So we have x squared times x, which is x cubed, and then we have x squared times 3, so plus 3x squared. And of course, to solve this polynomial equation, the first step in our algorithm is to bring everything to one side. So minus 20 equals 0. So you can probably see now that this would have been a slightly more complicated expression to expand, but even at that, not that much more. Would have been perfectly fine. So now I take a look at this polynomial equation. I see it's cubic. It doesn't have 4 terms, so that means grouping is going to be out of the question. So I'm going to have to start using the factor theorem to solve this. Okay, so I'll call this P, and I'll start going through my values here. So P at 1, okay, well here 1, 3, this is definitely not going to be equal to 0. P at negative 1, again, negative 1 plus 3 minus 20. There's no way that's going to be equal to 0. Let's test 2. That might have a little more of a possibility here. So here 2 cubed is 8 plus 3 times 2 squared. So 3 times 4 is 12. So 8 plus 12 is 20 minus 20. Yeah, there you go. That's equal to 0. All right, so didn't take too long to find that factor. So now I will do my division here. So I'm dividing by x minus 2. And don't forget, very important, there's no x term, so I need to include a 0 here in my synthetic division. All right, so bring down the 1. 1 times 2 is 2. 3 plus 2 is 5. 5 times 2 is 10. 10 plus 0 is 10. 10 times 2 is 20. And negative 20 plus 20 is 0, as I expected. All right, so that means that the left-hand side can now be written as x minus 2 times x squared plus 5x plus 10. And of course, we're looking for when that's equal to 0. All right, now I want us to keep in mind that the only dimensions they're interested in are integer values. Now here, I'm obviously going to get one answer, okay, that is going to be an integer. If I look at this polynomial, though, quadratic, 1 and 10 isn't going to get me to 5. 2 and 5 isn't going to get me to 5. So this is the only integer solution, okay? Even if the quadratic formula were to work on this part of the expression, it's not going to give me an integer value. So this is the only integer value. So now I can go back and input that into my 3 dimensions. So what do we have? We have a length of 2 meters, we have a width of 2 meters, and we have a height of 2 plus 3, 5 meters. Oops, height of 5 meters. All right. So this is the first time in this course that we're seeing a modeling function, okay? Where step 1 is to come up with a model that we'll then use to solve the problem. How did we do that? By working with a square-based prism. Okay, from there we were able to find an expression for each of the 3 dimensions, and then we use those expressions to write out an expression representing the volume of this box, and we use the fact that they told us the volume was 20. From there, that created this polynomial equation, which we can now solve with our algorithm for solving polynomial equations. Okay, that's it for this one.